Okay, so the next presentation is by Shim, and it's on the CCMC research and education resources for the CEDAR community. Thank you.
I'm very pleased to have a great opportunity to present the CCMC to CEDAR community. So I would like to take this opportunity to inform you guys about CCMC research and education resources for CEDAR community. First of all, I will briefly talk about the CCMC and then what ionosphere-thermosphere. Okay. Okay. It's better? Okay. And then what ionosphere-thermosphere models at CCMC are available for your research, and then how they can be used for your studies. And then I'll talk the CEDAR electrodynamics and thermosphere challenge, which was initiated last year at CEDAR workshop, and then CCMC is supporting the challenge. And finally, the outlook will be given. One of the main goals of CCMC is to support the space science research and education by providing access to modern space research models. And so we are developing the online visualization and analysis tools. And the other main goal of the CCMC is to address national space weather needs and support NASA robotic missions. So we are doing model validation and verification as an unbiased user. And we are running the model in real time. And also we keep developing space weather forecasting tools. The models at CCMC cover entire domain, from solar corona and heliosphere and magnetosphere and to the ionosphere of the Earth. However, today I'll just focus on the models of this ionosphere and thermosphere, even though these models are driven by these solar activities. These global ionosphere-thermosphere models provide parameters which describe these IT states, such as electron density. This is electron density as a function of height and latitude at a given longitude sector. This is obtained from the SEMI-2 models. And also, the global total electron content. This is from the USU game model, which is a simulated real measurement, such as GPS ground-based TC values. Also, these models provide thermosphere parameters, such as neutral density. This is from DIGCM model. This model has become available at CCMC since last month. Also, you can get the information from these models about the electrodynamics in high latitude, such as height integrated Peterson conductance. This is from the CTE model. So let me tell you how you can access these great models for your research. The first step you should do is just to make a request for the time period of you're interested in. And then once this model run is finished, and then you will be informed. And the model result will be visualized on the interactive web interface. And you might want to request for time series output for comparison between measurement and the model output. And also, the result of this movie are available on your request. And we store all this simulation result. So this extensive database can be used for your research and also the education if you are the professors. Okay, here is an example how you can use these online visualization tools for your research. Actually, I run the TIGCM for a certain event. This is 2006 AGU storm. And during the storm, KP values the reach up to 9, so it's kind of a strong storm. So from the run result, this is the maximum electron density during the storm onset and during the storm main phase. Actually, there is a significant increase in electron maximum density in high latitude, as shown here. On the contrary, there is a decrease in maximum electron density in middle latitude. Also, you can get some information on a specified location. This is electron density over Millstone Hill. And as you can see here, there is a big increase in maximum electron density, and about 4 times compared to the onset time. And 24 hours later, this maximum electron density decreases. However, the maximum height increases a little bit. So you might want to take a look at the neutral density or the vertical drift and neutral winds in order to find out which makes this kind of change. Also, this kind of information are available on the visualization tools. The same period, I have the different measurement. This is from USU game simulation result in the red, and black one is a result measurement from the Millstone Hill inquiry radar. And this is a time series output, so you can use the result for your comparison. As you can see here, USU game is kind of successful in the producing in the NMF2, but this doesn't catch this peak value. However, on the average, yeah, it does good job. And also, this tool provides you the model result along the satellite track. This is electron density along the CHAMP trajectory. And then black line is the real measurement from the CHAMP. And light blue is the model result from CTE. Even though the model doesn't catch the 2 peaks, related to the equatorial anomaly. However, on the average, yeah, it does a good job too. Also, we provide the tools for ionospheric monitoring in real time. You can get the information about ionospheric states in real time on this ISWA system. This is web-based dissemination system. We have abnormal model. This provides information about high frequency, the signal loss in D and E region. And also you can get the information about electrodynamics in high latitude from YMO model and also global MHD models. And recently, CTEP is running in real time in test mode. So this is reviewed by the NASA the mission operators. This CTEP can provide information about electron density and the plasma density along the ISS, the satellite tracks. We are going to have 2 more the models at CCMC. And one of them is ionosphere ventilation model, developed by the John Ratterer. And the other is GITM, the global ionosphere-thermosphere models, developed by the Aaron Ridley. And SEMI-2 will be upgraded to SEMI-3 soon. And so far, I talk about the tools you can use for your research and education. And now I'm going to talk about this CEDAR electrodynamics and thermosphere ionosphere challenge. The goal of this challenge is to help to do evaluation of these IT models. So this is not just one-time project we are going to do in routinely in order to see how these models improve over time. And through this challenge, the interaction between research and operation community will be facilitated. And also, we can facilitate collaboration between modelers and between communities, such as GEM and CEDAR. Next year, we are going to have the GEM and CEDAR, the workshops. Also, CCMC is also have been supporting this GEM modeling challenge. So we selected some events among the GEM modeling, the events, 3 of them. And also, for the study of the ionospheric climatology study, we select 1 year of incoherent scatter radar observation. And among these, the period, the 3 moderate storm and 3 quiet periods are selected for the challenge. For metric study, the several physical parameters are selected, such as vertical and horizontal drift at Hickramarkar, and electron density, and neutral density, and NMF2 and HMF2, and also global TC values. Let me show one example. So far, we have got. Actually, a lot of the comparison already has been done, but I just want to show one result. Okay, this is the measurement of the Millstone Hill, HMF2, and this is result from model 1, and this is result from model 2, and this is from the 3rd model. If you need to use one of those, which one would you like to choose? Actually, it depends on your application. So you can choose one of them, or you can just combine the several of them. So how to compare the model result? So let me show the 2 examples of metrics. One of them is the matrix based on RMS called model skill score. The model skill score is a function of model score and the reference model score. This model score is just a root mean square value against the real measurement. And if this value is larger than 0, means this tested model is better than the reference model. If this is less than, this value is larger than 0, this is better, and less than 0 is worse than the reference model. And the other example is the matrix based on ratio of the difference between maximum and minimum values during an event. If this value is larger than 1, that means model estimate the larger than the dynamics. And this value is smaller than 1, that means the model underestimated this change, the phenomena. Okay, this left one is a skill score for HMF2, and this right one is a ratio of maximum change. The red dot is the average for strong storm, and the green one is the average for the moderate events. And this black cross is average for all events. As you can see here, the most of models perform better for the moderate condition than a strong storm. And here, I just make one point. If we use this skill score to compare the model performance, in this case, the model 1 does the best job. But if you use this ratio, maximum change, and then this M1 is a kind of perform the less. So the ranking depends on metric selection. So as I mentioned earlier, it depends on your applications. Here is another example for this, the dependence of model performance on the latitude. This is a skill score for electron density and for low latitude. This is electron density skill score, the higher latitude. And this case, actually, the most of them does better job for the moderate and quiet period than strong storm conditions. So if you see this, the skill score for low latitude, model 1 does not good job. But however, if you think about this, the higher latitude, model model 1 does better job. So model ranking varies with the latitude. So if you are interested in higher latitude, you can choose model 1. If you are interested in low latitude, you can choose the model 3 or model 2. Okay, so far I just talked about what we have done for this challenge and one of this result. So if you are interested in this result, you can join us tomorrow, the SETI workshop in the morning. Okay, this is my last slide. So we have broad range of these IT models. So please take advantage of these models for your study. Especially, I encourage the students to use this model for your studies. And we are going to expand this validation, verification activity. And also, we will do our role in facilitating this interaction and co-work with the GEM and CEDAR community. Okay, thank you.